And hello, I'm Matt Clark, or Gray Skeptic. I'm here with Trisapient, or Ed Hernandez, and we're here to talk about his new book. Um, is it called Chemical Emergent Chemical
Evolution.
Evolution? Yes,
Yes, sir.
I should know that. I just titled this video that. I should have it down. Yeah, awesome.
Yeah.
So from what I understand, this book covers the mystery, or no longer a mystery, of abiogenesis to evolution. Is that
Correct.
is that right?
Well, it's basically the how life started on Earth,
Okay,
and
awesome.
the reason I called it emergent chemical evolution is just because of that it's emergent chemical processes that eventually lead to life evolving from that.
Awesome. Okay, great. Well, I'll let you take over for a second and just introduce yourself. To tell us who you are, what you do, um, what your book is about, and why you wrote it.
Okay. Well, my name's Eduardo Hernandez, also aka Trisapient. Uh, I'm the author of Emergent Chemical Evolution, the uh, how life is solved, how the beginning of life is solved. And I started on this journey way back in 1987. When I first read this book, this has a list of all the original articles written by the Nobel laureates who were discovering how life worked. So in this book, it had all the articles, the original articles of the first discoveries of DNA, of the the citric cycle, which is how life processes food. And I read that back in 1987. So from that book, I learned all the basic processes of how cells work. And in that book, it has several articles dealing with the origins of life. And they proposed their theories and whatnot. And to me, they seemed pretty valid, pretty, succinct. And I thought, hey, that's must have been how it happened. And from that time, when I was 17, I thought they had solved how life started. And I had that belief for almost 20 plus years until 2004, when I took a philosophy class and the professor said, hey, one of the great mysteries of life is exactly that. How did life start? And I was like, are you serious? No, it's been solved. He says, no, not really. And that same night, I went back and took out this book and reread it. Now being an adult and being already through college, I took a closer look at those articles, and he was right. They do pose some very valid, so what I thought were succinct theories, but they do not absolutely solve the problem. So I was like, wow, that's a big gap. That's something that needs to be solved. And me being an atheist and believing that we arrived here without any help from any deity, I said the problem can be solved, has to be solved. There is a solution. And I made that my life's goal in 2004 of solving this problem.
That's really cool. Um, so in 2004, you really started to like buckle down and just make this your life
My life's
goal.
goal. Yes, that was the year I graduated from my uh, associate's degree in chemistry.
Okay.
I was already 15-year professional in electronics by that point.
Oh,
I had
awesome.
already been working in electronics since 1991. So I was, you know, every day utilizing scientific methods to do my job. I was an electronics technician. I had to find these equipment, find what was wrong with them, and using science and what I knew of physics to to fix that equipment and solve the problem. And I worked on over 88 different types of equipment: computers, radar, radio, video, audio, anything they threw at me, I could solve the problem and fix that equipment. So by that point, I had already a uh, very strong sense of problem solving and complex problem solving, because these were complex systems. These weren't just, rinky dinky stuff. I'm talking about at that point in 2004, I was working on a high speed video delivery system that worked in the planes. So it was a big computerized system, and and you know there was different components that worked separately and did all types of different things, and they all had to work together. When that system failed, it was a big job to try to solve what was wrong and make it all work together. So I was already used to and had many years of experience solving complex problems. So I was very confident I was going to be able to do it.
And I'm a firm believer that like you need confidence to like solve a problem and really dive into something. If you
Yeah,
go in doubting yourself, it takes a lot
yeah,
longer.
a
Or
lot longer. Exactly. You're
yeah,
going to doubt every step. And
yeah,
and you know,
and that's good to a certain point. But
well, I was confident that it could be solved. Whether
yes,
I was going to be able to do it, that was a whole nother question.
right.
And to tell you the truth, my initial theory, uh, I had to drop actually several reiterations, several versions of that theory. I had to drop completely. The initial, the initial idea that I had for this theory, which still holds true, is that the ocean currents had something to do with it. Because I've had an experience when I was young. Um, for safety reasons, they put us in a circle, and they had us go around the pool, and going around the pool with the water around. And they said, okay, you, the biggest guys, try to get out of the pool. And with the water spinning, I tried to get out of the pool. And trying to get out of the pool, I lost my pants. And I still couldn't do it. That's how strong the water current is. And that's a lifelong experience that I've never forgotten. And I'm saying, these molecules don't have hands and arms. They were going to be susceptible to ocean currents. And the ocean, I had watched a program on ocean life, and they had said that the oceans, since the beginning of time, have never stopped moving. So all the currents affect everything in life, bringing food, bringing nutrients, bringing oxygen. So I was like, those things have to play an important part. So right there, that told me that these ideas of molecules reacting on the surfaces of rocks, or the surfaces of anything, is not going to be tenable, because those molecules won't be able to stay there. The water will come and whip it through. Uh, Point of fact, an inch of water has, in a straight line, 97 million molecules of water. Each molecule of water has an active hydrogen or an active oxygen side that will strip away or react with anything in its path. So just an inch of water passing by any molecular structure on any rock is going to cause havoc. It's not going to be able to just sit there and react and form any of these molecules that they're postulating.
Right. And I saw that in your summary, and I thought that alone was really cool to me. It's like
Yeah,
97 million.
yeah.
It's a lot of molecules in 1 inch.
Yeah, it is. It is. And I mean, that's just a straight line. Water is very fluid, so it's probably going to be a lot more than that. But I'm just basing it on the size of the molecule and the length.
Yeah.
Uh,
Um,
so, yes.
Something else I want to touch base on real quick, because you're being very modest. Um, I'd like to, I'd like to point out, or have you point out, how many degrees you have and where you went to school.
Okay. Well, I currently hold 3 quote unquote degrees. Yeah, there. Uh, I have my full on degree is chemistry, but I got my diploma for electronics from the military in 1991. But electronics has been my hobby since I was 11. So I already knew electronics. They gave me a paper saying that, I can work it.
Yeah.
But that's been my hobby since I was little. And that's what I've mostly done my entire life is work on electronics almost every single day. You know, one of my favorite things is to fix anything that's broke. So my wife gets on my case. You're not fixing anything. We're just visiting, okay? So I gotta, anytime I see something broken, I, get the urge to fix it. But and the other thing is, I've since 2009, they took my electronics job and they shipped it to Mexico, and I went and I even trained the people over there. So you know, it's not their fault. I went and I did the best I could to train them and help them because they didn't make the decision. It was some headquarters in Iowa, uh, making the decision. So I went to make some more money because I have a family to feed. So once that happened, I was able to qualify for a program to change my career, and I became a nurse.
Oh, gotcha.
And
So how long have you been a nurse now?
7 years now.
7 years.
And one of the major breakthroughs is thanks to that program. While I was going to school, I was still working on my problem, and I got one very important breakthrough. While I was going through nursing school, we have a part of the program where we have to determine the pH level of patient's blood. You're wondering, why does that matter? And it matters a lot. The pH, if it's out of balance, can cause you acidosis, which could lead to certain types of problems, or chelosis, which will go the opposite direction and lead to other problems. But the main thing that I got from that, which was surprising to me, is that you cannot have too much carbon dioxide or too little, because that changes the balance of the pH of the blood in the tissue. And the main thing which was totally surprising to me, was that you cannot have zero carbon dioxide in your blood or in your tissues. If you have zero carbon dioxide, you're going to die.
Mhm.
We're thinking like, oh, carbon dioxide is not good for you, but it is. It's the main thing that our cells use to maintain the pH, the homeostasis of the cell. And that blew me away. It's like, so carbon dioxide had to play a major part in the origin of life. And the fact is that at the beginning of life, there was no free oxygen. Up to 10% of the oxygen, they believe, was carbon dioxide. And the one of the things that's happening now to the oceans is called the acidification of the oceans, because we're pumping in too much carbon dioxide into the atmosphere.
Mm-hmm.
You want to know how much carbon dioxide it is right now? It's
I've heard, but I haven't heard a more recent number. Go for it.
it's 0.0034% of the oxygen is carbon dioxide, and that is elevated, causing the acidification of the oceans. That
Gotcha.
small amount, that small amount of carbon dioxide in the atmosphere has a major impact on life in the oceans. It's causing the bleaching of the coral reefs. It's causing crustaceans not to be able to form their protective coatings. So, that is a major problem for the oceans, but it's just such a small amount of carbon dioxide in the atmosphere doing that large effect. What we think would happen to the oceans if it was 10%, 10% would make the oceans extremely acidic. But that's not the end of the story. The carbon dioxide in the atmosphere would acidify the ocean, but it would more the interaction between the atmosphere and the ocean would cause greater acidification at the top of the ocean. So at the top of the ocean that touches the atmosphere, it's more acidic. But the deeper you go into the ocean, the less effect that carbon dioxide has on the rest of the ocean, meaning that the ocean, as it goes deeper, becomes less acidic, causing a gradient. So you're going to have different levels of pH in the ocean. That's very important. So as the world is round, on the top of the ocean, all around the world, there's going to be high acidification. A little deeper is going to be less, a little deeper, but all around the world. So the whole ocean, as far as we know, and from evidence of geography, was that the oceans were miles deep without any continental, without any continents, any continental plates. So it was all covered in water, and you had the whole world with this gradient of pH. And why that? Why is that important? Well, if you look at the amino acids that are delivered, well, amino acids in period, from all the amino acids that the human body uses, which is only 20, meteorites have been shown to deliver up to 70 different types of amino acids. The special thing about amino acids is that they readily bond to each other without any provocation, but they do so at different pH. Each one of these different amino acids has a preferential pH where they will easily bond to something else. And having the ocean in that gradient, the currents going through the ocean, through the different gradients, carrying those amino acids, once that amino acid reaches a particular pH, it will readily bond. So here you have all these pH levels being available for all these different amino acids to unite spontaneously. And that to me shows that there was tons of amino acid chains available for life to commence.
That's really cool. So with that, I want to throw out like my thoughts on that and just kind of life emerging in general. And now that I'm talking to like a scientist, maybe you can be like, okay, Mac, I think you're on the right page then, and you're understanding what I'm saying. Or you can be like, hey, you're way off your rocker. Let me correct you.
Well, as things stand right now, with all the different types of theories, you're going to hit one of them.
Okay, fair enough. Fair enough. Well, so because Christian apologists like to throw out, you just believe that things happen at random and that like just something comes from nothing. And, you know, if the universe was just, I forget exactly, like if proton, neutrons, if anything was off by just a little bit, the universe wouldn't exist as we know it. And my response to that has been, as random as like we see it, I don't know if there's any other way. Like maybe it's that way because it has to be that way for all we know, or it was close enough to this way that it had to be this way or a different way. It's just because things react, like you said, like with the amino acids in the water. It's not just like they just randomly did something whenever they felt like it. It's just when they get to a certain pH level, when they're bound to hit something to react. They're bound to, and it's just when they hit that pH level, it's going to happen. And just like more like cosmology, it's just when molecules react with other molecules in the vacuum of space, and that heat and like dissipating heat, something's going to happen with all of that raw material there. Like something has to happen. It's not just going to be as big as space is, just nothing's going to happen because there's material there. Something's going to happen. Does that make sense?
Yes, sir. You're absolutely correct. I can explain that even better.
Go for it. Please.
If you notice, whenever we want something, a metal, iron, or aluminum, what do we have to dig up? Do we dig up pure iron or pure aluminum? No. We have to dig up iron ore, which is iron mixed with oxygen and other chemicals, and we have to separate them. So in nature, you don't find pure elements. Almost everything reacts with everything else. And point of fact, these meters that we measure and test that come straight from outer space already have amino acids in them. So that means in the vacuum of space, when you mix atoms together, the first thing they want to make is amino acids. And you get 70 different ones. Now, how many does life use? Life only uses 20. It has a whole range of different amino acids to choose from, but it only used 20. I believe, and according to my theory, it makes sense. Yeah, again, it's a whole big book, and you have to read that section.
Yeah.
But the probabilities is that life came up with only 20 different ways to make amino acids, and it jump started from there. And the reason for that, I have what's called the Trisapient homolog process. It is a theory. Really, it's an observation of how molecules, how amino acids react, and make uh, how they bond together. And once they do, they make certain shapes. They make helixes, beta sheets, or curves. And what happens is they always do those things. They always either make one or the other. And once you get them together, it doesn't matter what's the exact sequence, but any amino acids will form an alpha helix, beta sheet, depending on the configuration. But the actual individual amino acid does not matter because of the structure that they all share. They all can either make an alpha helix or a beta sheet or a curve. That being the case, if you have a string of amino acids, their direct identity doesn't matter when they're making the alpha helix or the structure. The only amino acid's identity that matters is the one that forms the clef or the reactive center that makes that chemical reaction occur. So you have these molecules, these proteins that are thousands of amino acids large, but it's only a couple of them that actually make the reaction happen. All the other ones are support. So all the other ones' identity does not matter. As long as they keep forming the same structure that allows them to make the same reactive center and present those same amino acids in that area, you have millions of different combinations that can give you the same enzyme and the same reactive center. The point of fact, all life makes RNA. RNA is very important. It takes the information from DNA and translates it to make proteins. Those RNA are made by a particular protein. This particular protein has a particular shape. They say it looks like a hand. It has a thumb, palm, and a finger. And that shape is shared by all life forms, viruses, bacteria, fungi, and humans all use a protein that's shaped like that. But here's the thing. The sequence of amino acids between all of them are up to 45% different. Each one of them are different between each other. Up to 45% of their entire sequence is different. That's a large error. You understand? When we have something like a cell phone go off by 10% or a signal go off by 10%, it's impossible for you to communicate. So how does this happen? And I believe that the process I described in the Trisapient homolog process describes why that happens, which is what I told you. The individual sequence does not matter. What matters is the final product and the final shape of the protein.
Okay.
So hold on. And how this addresses what you were saying is that life and the processes that make up life are based on the chemical reactions that these elements do or take part in once they are put together. It's natural law because these are chemical reactions that cannot happen any other way. Oxygen is going to bond to something and cause the same reaction, regardless if they're here or in outer space, or within a human cell or outside of a human cell. These reactions are going to be the same. What's going to be different is when they get together as larger molecules and how they interact. But here's the thing. We live on the surface of the earth. We need oxygen. We need temperatures between 50 and 80 degrees or 100 or something. We could live in that. But we have found animals that live where? In the vents, the oceanic vents where basically volcanoes underwater releasing super hot water. But what do we find there? We find
Life,
life.
right? And
They're
it's
surviving. So to me, it tells me, okay, we don't have to be exactly in the Goldilocks range for life to exist. You have life existing almost in boiling water. It is boiling water, actually. It just doesn't boil because the pressure's so high down there. But the same chemical reactions occur. What makes it different is the structure, the amino acids that form the proteins that make those life forms take their shape in those conditions. Because if you take them out of those conditions, it's like either freezing them or boiling them. Because once you take them out of those conditions, their proteins will take a different shape and will not be able to form react the way they're supposed to react to continue the processes that allow that animal to live because they are evolved for those conditions.
right,
So life, even if the universe changed and the 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 parameters were tweaked, to me it would say, you know what, Earth, instead of being the size of Earth, would have to be the size of the solar system to be able to have enough gravity to pull the elements back together. But the elements, being how they're going to be, are going to react differently, but they're going to follow the same rules. And I believe that those same rules, which are very simple, if you follow the book, you know, are going to play regardless of how those atoms or the conditions they find themselves are. Life is going to come.
right, right. And two things. One, speaking of elements, carbon can keep his hands to itself, like Selena Gomez.
Right, exactly.
And
Wow, I wish that was true.
and Pompeii worms is are those the animals that you're talking about that are in the vents
Well, they live right next to them. Yes, yes.
right next to them?
And what they do is they take nutrients from the water, but they're animals basically. They're tube animals. Yeah.
That's awesome.
But it's not only there. I mean, them. There's crabs that live in those conditions. There's shrimp. There's fish. There's all types of. It's teeming with life. They're
Right,
all evolved to live in those conditions.
right. And then there's also the I forget what they're called. I think some sea bears.
The yeah.
That's
Is
one
it
name
sea
for 'em.
bears? The little tiny creatures.
Yeah,
They
and
look
they
like
can like
bears.
live in the
Yeah.
vacuum of space. And
Correct. Correct. Well, you see, there you go. I mean,
yeah,
there's
Water
so
bears.
they're
what
called
was that,
what?
Don?
Water bears.
Water bear. I think I've heard multiple names for them,
They're
but water
multiple
bears is
bears. Yeah,
one.
yeah,
Yeah,
yeah.
yeah. Thanks, Don.
But yeah, but
Tardigrades. Beach. Thank you.
tardigrades. Yes,
Tardigrades.
tardigrades. Yeah.
Yeah, we have people in chat naming
Yeah.
naming
Yeah.
animals and
Strange looking
tardigrades.
creature.
And, yeah, they are.
It has a mouth for a head
Yeah, it
and
does.
six little arms.
Like perfect for a buffet.
Yeah. So there you go. That proves my point. They want to believe. Well, I mean, they have a point. Life as we know it, life as it is right now, won't. I mean, I personally believe it will exist. It'll just be in a different parameters, but the same interaction with carbon. Carbon is going to be carbon, whether it's in this universe or another. It's going to be a six neutron atom with four valence electrons on the outside. It's going to allow it always to make four bonds with different elements. And as long as we have an atom that does that, it's going to lead to life.
Gotcha. It just can't help itself.
Yeah, that's why I call it emergent, because it's going to emerge regardless.
Gotcha. I like that. I like that a lot. And to what you were saying, where maybe they're right. Maybe it's not like life as we would know it, but it's Have you watched The Cosmos with Neil deGrasse Tyson? I haven't seen the.
I've seen only a couple of episodes. I watched the original one. Actually, the original one is what helped me become an atheist at 11 years old.
That's awesome.
Yeah.
Awesome.
That and Planet Earth by uh, what's his name?
I haven't watched it yet. I think I started watching it, but I didn't
Oh,
watch.
the original Planet Earth back in 1982,
That's
which
awesome.
showed the evolution of life with David Attenborough. That's what I was saying.
Okay.
He's a fellow atheist.
Well, they showed in one of the first episodes just like life on Earth used to be so different than what it is today. Not just like with dinosaurs, but even before that, I think it was. It was just like
Right.
just
You see the
gigantic
strange.
bugs.
Right. Well, that's right before, but you should have seen the ones that during the Cambrian era. They're super strange animals. I mean, they had all different types of body parts. They look totally alien. I mean, you can make a beautiful alien movie just from those animals alone.
I'd watch it.
Yeah.
Quick shout out to Mrs. Snarky and Godless Iowan. They made it to the chat here. So hi guys.
Hi guys, I follow you guys on Twitter.
Oh, and they just popped up too. Hi they. Some of the guys don't make it over here on these streams because they're too busy most of the time. I'm glad they can make a little time to come hang out with us. It's awesome. So back to it though. I just know like a speck of information on like what Earth used to be like, what evolution is really like. I understand the concept. I can't explain it as well as you can by far. So can you walk us through a little bit more like story mode on how your book explains how your theory explains this?
Okay. All right. Let's start with the late heavy bombardment. It's very important. According to geophysicists and astrophysicists, they believe that our volatile elements like water, carbon dioxide, helium, hydrogen, nitrogen, those things would have been burnt off when the Earth first accreted, which it would have all the meteors that formed the Earth and all the elements that it had would have melted into one big mass molten ball, which would have been above 2,000 degrees. What they believe is that at that temperature, the Earth would have been unable to withhold any water, any carbon dioxide, any of the volatile elements, nitrogen, all of those would have burnt out into space. As the Earth cooled and Jupiter formed, Jupiter then knocked those outside meteors on the outer solar system, which had frozen water, frozen volatile elements captured because it's so cold out there, and would have knocked those meteors and asteroids and comets towards the Earth's orbit. And that's what formed the late heavy bombardment. As they believe. No, thank you, because that's how we're here. So all those, the scientists believe, according to the fossil record, geographical record, that the Earth was bombarded for over 600 million years of daily bombardment of these meteorites and asteroids and comets, which each one of them, according to what we've studied from recent meteorites, these meteorites contain up to 20% water. That's a large amount. These are really wet rocks in comparison to Earth rocks on the crust. So drop by drop, with all these millions of different impacts, they formed the oceans, the atmosphere, all the volatile, the nitrogen in the atmosphere, all the volatile elements. 600 million years of daily impacts. It's mind-boggling, the concept.
Yeah, it's a lot, but it's like that's just a lot of raw material to work with and have nothing happen with ever.
Up to 70 different types of amino acids.
Yeah, and
each one.
Touching back on that real quick, you said it only takes 20 amino acids to form life.
Well, life discovered only 20 different ways of
Okay.
making 20 different amino acids.
Okay. That's what I was going to ask, because I've heard that there's, it's possible for like silicone life to.
I highly doubt that. I really
Really?
highly doubt that.
Okay.
The the reason why I'm saying that is because of the chemical relationship of carbon with the other elements. I can't see any conditions that would make silicon, which is a highly stable element and heavy, uh, to have conditions that will be conducive to life, that will make water. Water is very important. Without the water, I don't think life would happen, because water is very important for all chemical reactions that life is involved in, every single one. And water also holds the proteins, allowing the proteins to form the shape that they need to have to cause those enzymatic reactions to occur. So without water in the picture, I really doubt that the silicon-based chemical elements would have the means of forming the same types of structures that carbon does with all the other elements.
Okay.
Because in order for, because what they're saying is that at higher temperatures, at higher different gravitational conditions in another planet
Pressure.
might allow silicon to be the one to form those reactions, but I highly doubt it.
Okay. Now, Don in the side chat put that silicone life would need a methane. So what's your take on that? Why would you say no?
Well, here's the thing: methane, the molecule, although it at temperatures which would have to be higher temperature, lower temperatures, for methane to become a liquid, it would not have the properties as water. Water is a bipolar molecule. It has a side that's more positive and a side that's more negative, making it able to take different configurations and allow it to become acidic or non-acidic. Methane is a hydromolecule, and it's basically even all around. It has 4 different hydrogens connected to one carbon. It doesn't have any polar regions that are no bipolar. One side is more positive, one side more negative, allowing it to take different configurations, allowing it to take to release the hydrogen. Because what's important about water is when it forms a liquid, it disassociates one of the hydrogen atoms and allows it to become a proton, which allows it to become acidic. I can't see methane doing that at a lower temperature or in a liquid. So the carbon would hold it very strong and not allow it to do that. So the main important thing of life is that it has to have a acidic gradient in order for it to have different chemical reactions occur. So like I said, I just can't see silicon in any methane-based, liquid methane-based life forms doing the same thing that life does.
Fair enough. From that, for one, I can tell your stuff. You're a chemistry, for sure.
Yeah, I've always been interested in chemistry. I've been good at chemistry since I was young. The first time I read a book on atoms and nuclear energy and chemistry, I was in 6th grade. So I've been studying science since I can remember.
Awesome. And if I can remember now, you can't see the live chat, correct?
No, sir. Let me see if I can bring it up.
Okay.
No, I can't. No.
Okay. Yeah, that's all right. I can just tell you a little bit because they said excellent explanation. Mrs. Snarky said it's hot how smart you are at Godless Iowan, but I read that first for you. So I'm throwing that out there. And Mrs. Snarky also says, "Hail carbon."
Yes.
Yeah.
I'm in the carbon camp.
So everyone knows Ed here, or for those of you who didn't see at the beginning, Eduardo Hernandez, he is just using his phone. That's all he has to do this live stream with. So if you guys have any questions for him or me, just let Don know here in the chat, or me, because I'm also watching. I'm actually watching it a little more than usual. I'm trying to get used to it. So if you guys have questions, please ask.
And you got to get used to that. You got to be a good host.
Yes.
We want the show to continue for a long time.
I hope so. So yeah, if you guys have questions, please ask, because I only have so many. Evolution.
Well, I can talk more about my theory for hours. So don't worry about posing me questions. I still have a ton more information to share. I want this to be the most information-packed podcast. Video you've ever done. Another important thing about my theory, which is lacking in all the other ones, is that when you draw conclusions about what you see or what might happen in your theory, there should be evidence for it in life, or other scientists must have those type of results in their fields or their observations or their published research. So that's the one thing about my theory that I think debunks all the other theories, is that every time I come to a conclusion in my theory saying, okay, if this is true, if my theory is true, then we should find random amino acids. Random RNA molecules that propagated throughout the system. And what I learned in biology was that viruses were protein coded RNA molecules. In a virus, you have the RNA, and then it's encoded, covered in a protein coat. And that protein coat allows it to infect other cells and become parasitic. I was not aware that there are a type of virus that does not have a protein coat, that is only composed of RNA. And it can propagate between different animals without anything, it doesn't need to penetrate. And they're called viroids. And here's the important thing, because I said in my theory, it says that you should find, because the amino acids were reacting in the water, would make RNA, but random RNA, that these molecules would exist. And as it turns out, viroids are RNA only that infect live cells and propagate. But here's the one thing, the reason why they're called viroids, which is void of proteins, that RNA does not encode for any proteins. Other viruses, the RNA that's contained within them is the information to make the protein coats and to make copies of itself. But these molecules of RNA do not encode for any protein whatsoever. Their sole job is to go in and be reproduced by the molecules in the cell. Now, according to my theory, at the beginning of life, we had an ocean full of molecules of protein, amino acid, segments floating out through the ocean, interacting and producing RNA. Now, here's an important thing also. If you look at simpler life forms, because all current life forms have mitochondria, at least the eukaryotic animals have mitochondria. Mitochondria are the powerhouse of the cells. These are the organelles that allow a cell to process food and have energy. Now, there's E. coli. E. coli is the bacteria in our gut. It is not a eukaryotic. It does not have a nucleus. It does not have mitochondria. The way it works is the molecules and proteins that are present in mitochondria that allow it to process food are located on the cell wall of the E. coli. The E. coli does not have mitochondria. It is so old that it allows itself to process the energy through molecules in its membrane. So that is a very ancient animal, the E. coli. The way E. coli makes RNA is it encodes small chains of amino acids, that up to 12 of them, 12 small chains of amino acids that have to combine to each other and find an amino acid and react with that amino acid to make a monomer, or a small part of the RNA molecule. That's how it makes RNAs. Higher life forms like ourselves have one big, large protein that does multiple things. It does up to 3 things to make an RNA monomer, all in one large protein. But this ancient animal has 3 different, 12 different encodings for small amino acid chains. Not only is it the 12 different ones, but according to what they've researched and when they've done the decoding of its DNA, these different amino acid chains were encoded in the DNA at very different points of time, meaning some were encoded in the DNA earlier than other portions, meaning that at some point in time, that animal only made small small amino acid chains to interact to make RNA. Where were the other ones? Where were they available? So according to my theory, all throughout the ocean, these small amino chains were available. So as these animals, or life in general, started progressing and started gaining more genetic information, they started encoding for the available amino acid chains that were available in the environment. And the ones that encoded for them first had an advantage, and they were the ones that progressed because they were able to process the RNA and use up the molecules faster than any of their neighbors.
Can I ask a couple
Yeah.
questions?
Yeah, knowledge bomb. Yes, Don, please ask Beach's question.
First question is from me. When you use the word theory, are you referring to the colloquial use of it?
No, sir. No, sir. I know that was that I was going to address that shortly. But that was my point when I was saying that all the other theories posit things, but they don't have any positive confirmation with any other research. They don't have anything that says what they're saying is true. They do perform experiments in controlled environments in their laboratories that gets them to those results, but they don't find any of those things in nature, in life, anywhere else, in any other of the other fields of science. Now, that's why I was talking about E. coli. E. coli is doing exactly what I posited in my theory. I did not know that beforehand. I looked for it and found it in E. coli when I did a search looking for small molecules, small amino acid chains, and that's all I did was small amino acid chains, and it led me to E. coli. That's how E. coli starts the process of making RNA. They have to take these small chains of amino acids, and here's another key thing. What are they doing? They're not taking carbon and elements and all that and making them into RNA. They're taking an amino acid. These chains of amino acids are taking another amino acid and changing it to become RNA. So its starting point is amino acids. So you have amino acids interacting with amino acids to form proteins, who will again take amino acids to make another molecule. And according to the heavy bombardment, the ocean should have been teeming because there were 70 different types of amino acids available at that time. The ocean should have been teeming with them. Think of Legos. You have a molecular Lego, amino acids taking and forming together and taking a Lego and making something else. So to me, it's inconclusive.
For something to be a scientific theory, though, be there'd be the research papers as peer reviewed and everything.
Peer reviewed, yes. All, and that's what I was getting at. So that's one thing I found. Then I found that again, the viroids, that's another thing I found. I found, these are things I was unaware of beforehand because that's not my field of study. So these are things from biology and virology and microbiology. And so I kept coming up with things that I should find, and I kept finding them in different portions of science. And here's a collection of all the papers that I found of positive research, that all the different things I theorize or evidence of the things I theorize should be available. So these are all peer-reviewed journals, and how should I put it? These are PhDs doing their research. These are published positive results for their research that are peer-reviewed in journals that are accredited journals. So as far as I'm concerned, there's no doubt of the validity of these findings for these individuals and their research. Me finding their research led to it by my theory gives credence to my theory. At least that's what I believe.
Okay. Beige wants to know if you know about Nick Lane. And
yeah, of course I know Nick Lane. I don't know him personally, but I've seen all his lectures. And he in one of his famous lectures, he said that it's a quote that I remember because it had everything to do, because I was really worried that he was stumbling upon my theory, was that there was a need at the beginning of life to have a gradient, a proton gradient, he calls it, which of course is a different, protons are what water releases into when it disassociates a hydrogen. That's a proton, and that's what makes water acidic. So he was saying there was a need for a proton gradient, and that back at the beginning of life, there was no cell wall, whatever that means, he said. And my theory posits that there was no need for a cell wall at the beginning of life. To me, that's a big jump, going from molecules to a complete cell. That is untenable. What else did you say? I'm sorry, I didn't mean to cut you off.
No, that's what she wanted to know, if you knew about that.
Yeah, no. He was one of the ones that came close to following the line that I followed. He just got diverted by the other theories. Because he's still doing the research with instead of volcanic vents, he's doing I forgot what they're called. They're chemical vents that are percolating oxygen. Percolating hydrogen vents that form the dead city, he called it, or something like that. It's damn, what's the name of it? It's a chemical reaction that occurs with water and a rock, and then that releases some form of carbon. And he's theorizing that at the beginning of life, that's what jump-started life, which I, of course, believe is totally wrong.
Okay. That's all.
I'm aware of him. I'm aware of Jack Shostak. What's the other guy? All of them that are, if they're on YouTube, I've seen.
And Godless Iowans asking if you could talk about burning silicone and how it doesn't work the same as burning carbon.
That I don't know. That's a physical process that I, like I said, the even though they have the same valence shell, the outer shell, the inner parts are much different, allowing silicon to become very brittle and very metallic. It's a semi-metal. So That's why, I don't believe that it would have the same properties once it became a molecule and suspended in water or even in methane, that it will be capable of forming the long chains and taking the right configurations, conformations as carbon does. So that's why I believe that that carbon did the job where nothing else will, because of its lightness and its ability to take that shape and react the way it does. I
Carbon
don't
just
believe
wants to do something all the time.
always. Yeah, yeah. It's a whole.
It's oh, can't keep my hands to myself. Okay. Awesome. Also, Beige said that she doesn't feel as smart as E. coli, or yeah, right now does not feel as smart.
No, don't feel that way. It's not your it's not your passion.
Not you.
It's not your passion. Everybody has their own passion, their own niche. So don't feel that that me being a geek about what I love is any reason for you to feel any less.
Yeah, yeah. I mean, I'm a firm believer that everyone's like smart at their own thing.
Exactly.
You know,
Yeah.
like
Yeah,
I
you're
don't
martial
know.
arts. You're martial arts. You know things about martial arts and what the human body can do that I would never even could imagine.
Right, yeah, and I could teach you a lot about that, but when it comes to evolution, I feel like a numbskull. But it's like that for like everything else that I don't study, like
Right. True. True.
studying
Yeah.
something, diving into a subject is how
Right.
you learn something. And if you haven't done
Right.
that, it's fine to feel
Well,
dumb. That's why you're not
I'm
an
glad
authority.
you're saying that. I'm glad you're saying that. That brings up an important part, which is why I feel like I was capable of solving this problem when so many other people were unable to do it. You got to understand, I have three fields that I work in professionally, day in and day out. In electronics, which is physics, chemistry, which I studied because I was passionate about what I was trying to solve, and I became a nurse, which is biology. And I've always studied biology my entire life. So as a matter of fact, I majored in it for a while until I changed later. And because I wasn't able to get the information I needed to change to chemistry to get the information I needed for my passion. But the point is that I can look at any of these problems from multiple angles and have experience solving problems in those different fields, which allowed me to learn the different things I learned and apply it to solve this problem. My major breakthrough would not have come if I did not go to nursing school and find that out about the pH balance of the bloodstream and the human tissue. I was unaware of the importance of carbon dioxide in the protoplasm, not the protoplasm, the endoplasm.
And see, now you know the difference between endoplasm and
Protoplasm
protoplasm.
doesn't exist. Protoplasm is from Ghostbusters.
Oh, okay. You could have fooled me. I forgot that was a Ghostbusters reference. Uh,
No, but so I believe that these other scientists, you have a physicist trying to tackle a life, a problem about how life started when he doesn't know very much about biology. I don't see how that's possible. You have Nick Lane, he's a great biochemist. He's awesome, but he has no idea about geophysics and astrobiology. I mean, astrophysics or anything about chemical interactions outside of his field. I've been exposed to all of them. How chemicals react in electronics, how chemicals react in the human body and outside of the human body. These are things that I became aware of through my experiences.
yeah.
I like to tell my friends I would not change a single thing in my life for fear that if I change anything, any hurt, any reason to cry, any of it, I wanted to say exactly the same because anything that changed could affect me finding out my theory or having my beautiful wife and my 4 kids.
Yes. One, astrobiology would be awesome. Two, someone should tell Ken Ham all of what you just said.
I'm dying to get him. I'm dying to debate him, bro. I'm dying to debate all of them and flat earthers. Oh man,
Yeah.
I didn't just learn about that from watching the non sequitur show. Oh,
Yeah.
thanks you. Thanks to you is how I came across the non sequitur show.
I'm so glad because that's a fantastic show. They have so many
It is.
subjects,
Yeah.
and Steve and Kyle are just brilliant.
No, they just yeah, they are. Yeah. They just had this guy, a geophysical geocentrist.
Mm-hmm.
That's another guy I want to tear up. I'll tear them all up.
I don't know if it happened yet because I haven't had a lot of
No,
time.
I did. I just saw the
Yeah.
It was yesterday. Yeah, yesterday, the day before yesterday.
Was that him debating the flat earther?
No, they just had. Yeah, no, they were interviewing him on.
Okay. Yeah.
It was the night before last. Yeah, because yesterday was with the social interaction, social something, social. It was two atheists, so they were going back and forth on social issues.
Okay. Oh yeah, I think I saw that Sargon of Akkad and Brittany.
Right,
Someone.
exactly.
Yeah.
Yes, sir.
I didn't get to watch it yet. I work all night
I
tonight,
said part.
tomorrow, and the day after.
I did.
So
I was working
download
too,
it.
and I was trying to hear it, but I couldn't.
Yeah. It's hard to keep up, but it's
Yeah, I know.
it's
When you work at night, it's impossible. Yeah.
Yeah.
Like weeks and days just fly by like nothing.
Yeah, they do. I have another question here. B says, what has been the response to your book so far?
Sorry?
What has been the response to your book so far?
Well, I got my first five-star review just the other day.
Oh, that's
I was
fantastic.
super happy about that. Yeah. I'm amazed I haven't gotten a 1-star. You know, that's people are so negative, especially when you attack their favorite theory. You know, some people are just. If you've seen some of the debates between RNA world and metabolism first theories, and when they go at it, it's like they're both wrong. So it's a combination, so to speak, because of my theory is a unique stance. Nobody has. I've been looking and looking to see if any of the theories come even close, and none of them do.
Gotcha. Now,
but again, you know, these findings here are from so many genetics, microbiology. Unless I knew every single research paper put out in the world, there's no way I could have, incorporate this into my theory.
Right.
You understand? I came across these things solely led from my theory. To me, these are positive evidence for the validity of my theory. That's why I say it's a theory, not a hypothesis.
Right. Mm-hmm.
Because my theory has led me to all these findings, which are by PhDs, peer-reviewed articles in accredited journals. So this is just not something that I found in a post or somebody's blog. These are real findings. These are real results that are positive that I found by following the conclusions of my theory.
And
as a matter of fact, I found 3 more that I'm debating whether I should include them in the book or not.
Oh, gotcha. So to me, so far, this makes sense. Again, I can't explain it, but the way that you're explaining it, like it seems to follow. Like it's definitely like a sequitur instead of like.
Well, I have a section in my book that explains why the other theories are untenable. I call it. I can't believe I'm zoning. Sorry, I'm a little bit nervous. This is the first time I appear on YouTube.
You're good.
On any live streaming period. Jesus Christ, honey. Can somebody help me? No, just kidding.
You're on your own. You're the smartest guy in the room.
Yeah, I know. Anyway, there's a middle section that explains the other theories and why they're untenable. One of them is that they make such a large jump from the metabolism to a cell, which You know, here's the thing. Occam's razor. Most people get it wrong. Occam's razor, they say whatever is the simplest explanation is the right one. No, that is not true. Whatever is the most probable or the most, sensible explanation should be the one taken, not the simplest. Because if you look at the citric acid cycle, that is a very complex cycle. It is controlled and manipulated by large proteins. What they focus on is the end products of the cycle, the molecules themselves. But they're saying if we find these molecules, then it would eventually lead to the proteins coming, and it just doesn't make any sense to me. It's in chemistry. There's no way that you can go backwards from the compounds to the proteins. That's like saying you find a physical way to make milk and a cow to come up because you have milk. It's or let's use a physical process, like cars. That's like if you take the exhaust of a car and you analyze it and you're able to tell which car made the exhaust. You can't, because you're going to have the same types of stuff that all cars make. And even if certain cars are more efficient or less efficient, they use a certain type of, that just complicates the issue. You use a certain type of gas, you use a different type of oil, it all makes it all different. It's impossible to go reverse. So my theory, step by step, uses chemical processes that are observed in modern life and that are evidenced in modern life. I took all these pieces, put them together, and then the results are available in other research papers. So I feel like these other, they're grasping at straws and making claims that, to me are untenable. I mean, it just makes absolutely no sense how metabolic products are going to lead to proteins and other things that are going to make life, let alone produce a fully functioning cell wall.
But the amino acids can do that pretty easily.
Well, what the amino acids do first is they make RNA. RNA itself has one proven chemical reaction that it does. What RNA does is cleave molecules. Cleave itself, auto cleave. It can auto cut itself. Our RNA does that. It auto cleaves itself. And if you look at the ribosome is the part that translates transfer RNA into protein. It takes the information, reads it, gets a transfer RNA, and takes the amino acids and puts in a certain sequence. The part inside of the ribosome that does the cleaving, that separates the RNA from the amino acid, is RNA. It's a complex of RNA. If you remove all the proteins, that still does that part, which is cleave RNA. So what I posit is that the RNA formed molecules, and they got to a certain size that became stable, allowed them to be able to survive in the environment, which is what they do now. And with all the other amino acid chains out there, there was the probability that there were other amino acids that would bond and allow them to multiply or replicate those RNA molecules and form another chain of RNA molecules. Once that happens, errors are introduced. It could become shorter and form transfer RNA, or become longer and replicate itself, but in a sense that it has addition mutations where it becomes larger and larger and larger and form ribosomes. So I'm saying that once that occurred, then you had a translation system in place. And albeit like viroids, they do not, uh, they replicate, but they don't code. So the viroids will continue to replicate themselves or cleave themselves and form transfer RNAs, or replicate and form more ribosomes. And that's the point at which life continued. After that point, where you had a translation system and a delivery system with the transfer RNA and the translation system with the ribosomes, then you can have RNA that would eventually start to code for proteins that were functional. Once that happened, then what you would start seeing is viruses. You would see RNA that would code for certain proteins. These proteins might become associated with those RNAs, and then those RNAs coat the protein, and there you go with the first virus. Here's the thing. TMV, which is tobacco mosaic virus, it is a single strand of RNA covered by a complex of proteins. The proteins form blocks, and they cleave together and form a rigid structure that's a big rod. And they're perfectly aligned to withhold that one strand of RNA. The only way that that RNA is released from that structure is when the pH of the surrounding solution changes. When the pH changes, that protein loses its structure because it no longer can hold the same shape, and it releases the RNA. Once the RNA is released, it is copied by whatever mechanism is available. It could be within the plant cell, another cell, or a dish, and it will replicate itself. And then once it reaches the right pH again, those proteins start getting rigid, start attracting each other, and start attracting that RNA and form a virus. So I believe that was the beginning of how life started. It started as viruses. And that's another thing that people are not going to like. So
now, why are they not going to like that? What's
well, because they think of virus as a parasite, as and they can't see how it can work without a cell. But what they don't realize is that what's important inside a cell is not that it's encased, is that that cell is able to maintain the pH of the endoplasm. So it maintains the pH inside of it that allows these proteins to do their job. It's not that they're encased and protected from the environment. What it is that since oxygen was introduced into our atmosphere, it changed the pH of the whole ocean. So then the cells had to develop a cell wall and a system of homeostasis, a system of homeostasis to maintain the environment inside of that particular pH. And there's different viruses react at different pHs. There's different bacteria that work at different pHs. You have bacteria that work only in very acid environments. You have other ones that are in less. How did that happen? You had to have an environment that was extremely acidic and that continued to survive in that environment to this day. So my theory posits that because of the gradients in the ocean, and the oceans covered the whole world, that at different points, the proteins that were activated at that particular pH would react with other proteins that are activated in that pH and form viruses for that pH. So any random chain of amino acids that worked at that pH would only work at that pH. So whenever the currents brought them together and that pH, they were all present, they all react only at that point. Over time, then you had viruses that only worked at those pH. Over time, viruses became more advanced and became eventually cells. Now, if we look at the virus is a very large virus. It's almost the size of a cell. It does all the work as a regular cell except replicate itself. It processes sugars, it processes amino acids, it does everything except replicate. Basically, it's most scientists prior to in the last century believed that viruses came about by the degradation of cells. That to me makes no sense. You can't degrade enough to reach the TMV virus. Get proteins to align so perfectly that they only hold one strand of of RNA. How can you degrade the proteins of a whole entire cell get to that point? Now, of course, they could say, "Oh well, it degraded and then went back the other way," and yeah, but you know that really that's to me is grasping at straws. To me, everywhere you look, you'll see that there's a pointing from simpler to more complex. E. coli to higher cells, the same thing. You have smaller, uh, less complex equipment evolving into more complex equipment. Same thing with viruses. Cells don't spontaneously form in a petri dish. You can take all the components of a cell, put it in a petri dish, put it in perfect conditions, and it won't reform itself. You put all the components of a virus into a proper condition and a proper pH, it spontaneously reforms itself without the aid of any other outside molecules.
Hmm.
That to me is a very, very big red flag.
Yeah, that's
the other
notice.
the other issue is the genetic processes of viruses. They have several different ways of replicating themselves. You have RNA viruses that have a single strand. You have viruses of RNA that have double-stranded, multiple double-stranded, DNA only, DNA to RNA, and back again, which are called retroviruses. They have so many different types of proteins that control these different replication systems, which none of them are available in the cells. The cell only has DNA and RNA in a particular way, but it doesn't have all these different types of different genetic systems. And they, again, the cell cannot self-assemble.
Gotcha. And RNA can.
Right. And the other thing is, this is another thing that according to the research that they've done on the history or the genetic evolution of the proteins available now for replication, they believe that in the past, those mechanisms were attached to membranes. So if you look at viruses, they're basically just the protein coat. Everything that a virus has and does is attached to its protein coat.
Okay.
Unlike the cells now. Most of the cells don't. So that to me also is another thing that points from viruses to cells.
Hmm. All right. Real quick, I want to point out that I only have about 10 minutes left, and then I actually have to get ready for work for the night.
Not a problem.
But
I still have a ton more stuff. It's okay. Just get my book. I explain it more succinctly in layman's terms. It's not. I tried as much as possible not to put any math, but there is some math I had to. It's unavoidable. But it's simple math.
Yeah, math's important though. It helps.
It is because in this case, it shows that my theory is more probable. I mean, certain mechanisms that I work out the mechanisms of what's the probability of a certain type of molecule to form, and I go through that in the book.
Okay. So questions here. Reese jumped in and asked, why is oxygen poisonous, but why do we need it to survive?
Oxygen was poisonous.
Was poisonous. Okay.
Oh, still is. It still is for certain life forms that are only adept at living in an environment where there is no oxygen. Excuse me. The reason is that those molecules for that particular life form evolved in an environment without the presence of oxygen. So once you introduce oxygen, it's going to react with the protein coat, with the cell membrane. It's going to cause havoc. Oxygen is a radical. It reacts with almost anything, which is what makes water. So 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 such a universal solvent. Water is a universal solvent. It can dissolve everything. There's very little that it cannot dissolve.
Mm.
And even
Okay.
then, it's only at a particular condition, because if it reaches a certain condition, it'll still dissolve whatever it wasn't able to.
Okay. And then someone asked again about peer-reviewed papers, because you haven't turned anything in to be like peer-reviewed, right?
It's so hard to put my. You saw how long it took me to try to make a summary for you.
Yeah, yeah.
It's such a complex uh, uh, process that it's very hard to sum it up into a small paper. I mean, I think of my book, people have criticized my book as being too short because it's only 135 pages. I don't look at it as a book. I look at it as an extremely long article, because I don't put the history of past events in the search for life. I don't put explanations of other theories and why they don't work. I only explain certain things of why the other theories don't work, but I don't go into the history of it, who started it. These are things that you find in all these other books. They make their books thicker by putting in the history of the search for the answer to the origin of life, and fighting about why the other theories shouldn't work or work and theirs should. But mine is strictly just trying to explain my theory and what I have found, and I'm trying my damnedest to get my book into the hands of people who can critically assess it and take the time to criticize it. I'm unafraid of anyone taking my book or debating me about my theory. I want them to. But like I said, me coming across these articles, research papers that are peer reviewed and published in credible journals, tell me that I'm on the right track.
Yeah, they all point towards your theory.
Well, they all give results of what my theory says should be available out there.
Yeah.
Because these are things that I had no idea existed. These are things that I was unaware. These are conclusions that I came to based on what my theory says should be present and available out in life.
And for those of you who don't know, Ed and I have been in contact for 3-4 weeks now, and that's something that I got right off the bat with him, is like bring people in who like know this stuff so they can ask me good questions and like poke holes in it.
Well, as a matter of fact, let's address that. I got an invitation from Non Sequitur to appear on the show.
Yes.
I suggested to them for them to get Aaron Ra, who is one of I think the most premier YouTubers who has studied and tearing apart all the theories on abiogenesis. So
yes,
I think he would be the most. I hope. I mean, I already sent them a copy of my book, an ebook copy, and some reference material for them to present to Aaron Ra and see if he's willing to come and cross-examine me on their show.
That would be really cool.
Yeah. I really respect the man. I've been following him for years, so that'll be awesome.
It's awesome. I'm not seeing any more questions right now. I'm seeing that we still have 12 viewers. I'm not sure how accurate this is on mine, but from what I know, it's pretty accurate.
How many do you usually get?
I get around this many usually. Off and on, it stays around like between 10 and 15. Like I'll lose some, more will jump in, lose some, more will jump in. Not just still here, because you can't see the live chat.
Yeah.
I
Sorry
know
about that, guys. The
Not
thing is,
to
I use Linux in my desktops. I haven't taken the time to figure out how to do a YouTube on.
I like
on
you
Linux.
already. You use Linux.
Yeah, I've been using it since 1996, before it had a user interface.
Cool. Yeah. And But I was going to say that Mrs. Snarky, got Godless Iowan, Nacho Witness, and a few others have all started following you on Twitter. So
Oh, cool.
You have some more atheist eyes on you.
Awesome. Hey, let's get together.
You buy the beer.
Yeah. Speaking about that beer, I've been ignoring mine.
Yeah, drink up. I got a Mike's Harder.
Mike's Harder Ale.
Cherry.
Harder Ale. Oh, I gotta try that.
It's gonna be a long night of work, so I thought I would pregame it. But cool. Cheers, Mrs. Snarky.
Cheers.
Yeah.
So
yeah, go on.
I don't know if you want to continue at another time.
I would love to have you back on. It'll give me a little
we
more
could
time.
We could do a flashback.
Atheist flashback?
Yeah. I used to be I used to be all kinds of things, but the thing I was when I became an atheist was a Jehovah's Witness.
Oh, fun. I had Fenrir on.
The non. I saw that you interviewed someone already.
Yeah, so that would be really cool because I'd like to keep up on that
series.
They
had some crazy beliefs.
yeah, they do. Very cultish from what I've come to understand.
Oh my goodness, yes. Thanks to my mom was smart enough to get out of there.
Say what now?
That my mom was smart enough to get out of it.
Oh, that's wonderful.
Yeah, but now she's a Catholic.
Oh no. I used to think Catholics were like the worst.
No, they're cool. I love it. I love the symbolism, the rituals. It's so cool.
Yeah.
And the architecture is beautiful.
Right. The thing that I really didn't like about Catholics, as like a fundamentalist Christian, was that like they just don't follow the Ten Commandments so well.
They
like when you look at the ideology and stuff, and just like
they make up stuff as they go.
They do, but they're like the perfect specimen for like evolution of Christianity. Yeah, it's just like they'll just form into whatever they can.
Yeah, you can find a Catholic that believes everything or anything.
Yeah. So it's fun. I would really like to debate a Catholic on something. Just to be like, no, because this is what you're supposed to believe, and this is what is true, and separate them out.
No, impossible.
Nacho Witness asked if we had any of our superhero questions yet. I usually don't do superhero questions, but I'm always more than happy to ask. So do you have any favorite superheroes, Ed?
Iron Man.
Iron Man.
Okay. Yes, sir. Tony Stark used his brain to have everything he has.
Okay, you're losing Twitter followers now.
Oh no! Don't listen to him. If you say anything other than Batman, Don gets pretty offended.
No. I'm sorry. I've always that's another one of my favorite ones because he's a human being. He uses his smarts and his skills. He doesn't have any of these supernatural powers.
But he's got cool toys.
Yeah, I love his utility belt. Oh man, that's the best.
Yeah. He's awesome. I like Green Arrow. Dick
Arrow
Grayson. I really like Dick Grayson. Actually, my son is named. A lot of people don't know this yet. I should have saved this for a Q&A. But my son's name is Oliver Grayson Clark.
Oh wow!
And I did that on purpose. Oliver Queen, Dick Grayson. And my last name's Clark, my favorite Superman. So I'm just like, I got that one nailed down. Don't even have to fight for it. So yeah.
Try it.
So for anyone who doesn't know, and Mrs. Snarky says, poor Aquaman. He's no one's favorite. Not even his wife's, probably.
Well, I learned how to swim mimicking the 1970s show of Aquaman.
Oh, hot dog. That's awesome.
Yeah.
That's awesome. God damn it. And Nacho Witness said, Seaman is Godless Iowan's faith. Seaman. I
Is
could
it
have
white
just let that
semen?
stay
Is
in
it
the
white
live
semen?
chat.
Oh.
He loves semen. It's his favorite.
No, I had a friend of mine. His name was Blanco, which is Spanish for white. So he went to the Navy. So he was Seaman Blanco, white seaman.
That's the best.
Oh,
All
that's
right.
another thing. Yeah, well, I already touched on that. I was a veteran. I was 8 years in the military during the Gulf War. That's where I got my skills in learning electronic repair.
That's really, really cool. And how long did you serve again?
8 years.
8 years. That's right.
For
Said that.
active during the Gulf War, and then for National Guard.
Cool.
And in the
Very cool.
military, when you know electronics, they expect you to fix everything.
I bet. I bet they
You
do.
can't tell the colonel, the general, no, sir, I can't do that. No, you don't say that. You just go and you do.
Yeah. I mean, I can kind of see how. I mean, the military is not like what is it for? It's more what it can do. So
Right,
if you
right.
can do electronics, then you are doing electronics.
Yeah, yeah. No, and they put me to do all kinds of things. I worked on radar, satellite communications, radio, and my main MOS, my main job was computer electronics. But I got
Okay.
to do all kinds of things.
That's cool though, because it helps you grow.
Exactly. I was never scared of a challenge.
Yeah. Another cool kind of question. They were talking about your background a little bit.
Hmm.
It's electronics,
Well,
chemistry.
hold on. It's a little, like I said, I've loved science since I was young.
Yeah.
Electronics have been my hobby since I was 11. But
Right.
I also studied astronomy. There was a time that I was going to be an astronomer, but I
That's
found
my
out how much
favorite.
they make, and I was like, nah.
That's fair.
and how much you have to go through to get a grant and to fund your work. I was like, no, thank you.
Yeah.
I learned that while I was a young teenager. But I was in the Renaissance program, which was an enrichment program during high school for college-bound students. So I went to school 6 days a week, 6 weeks out of every summer. I would go to stay at a campus, Stevens Institute of Technology. So I was on campus for 6 weeks, getting classes during the summer, and they would take us on trips to IBM, AT&T, all that kind of stuff. But my senior year, I was put in touch with the professor at the Institute of Animal Behavior at Rutgers University, and I was hired to work at their lab under a grant from the National Institute of Health. So I was already working in the research laboratory before I even left high school.
That's awesome.
That was back in 1989.
Do you know what happened with me in 1989?
You were born.
That was my origin of life.
So what?
I said that was my origin of life. Yeah, I was born.
Yeah, I'm an old geezer.
And I'm a millennial, and I'm
Yeah.
more ashamed than you should be.
No, don't. You were born and you're living the life, man. You guys are born in the perfect time. Watch Gary V, and you'll see
Gary
you're on
V.
the right path. Yeah,
Okay. Yeah, on YouTube.
yeah,
Oh no,
yeah.
Gary
He's
V.
all over the place. He's everywhere. Gary V. Yeah.
I've lived under a rock most of my life, so you guys gotta tell me where things are.
You live in a small town?
Kind. I mean, I live in Northwest Ohio, so I've always kind of like lived in the suburbs,
Oh yeah,
more
yeah,
or less. I've lived in out in the country a couple times. Kind of moved all around Northwest Ohio,
yeah.
but it's mostly cornfields up here. There's not a lot to see. And when you live like a Christian fundamentalist life like I did,
yeah.
you're pretty sheltered from science.
No, I know
So
that's how I was. That's what led me to atheism, because I was trying to because as a Jehovah's Witness, you would get Bible studies, personal Bible study in your house.
yeah,
So they would come to your house and train you on reading the Bible and lessons from the Bible. And I was learning science at the same time, because my mom, since I was young, she put me in front of the TV on PBS. So I basically grew up on PBS. And I was trying to make it work, the Bible and science. And they would tell me, no, you're wrong. Okay. So it got to a point where they kept changing my tutor to the point they had an elder, and I was like 11 years old. And they brought the elder. He said, "Do you believe the Bible?" I said, "Yeah." At that point, I was really not, but I know what he wanted to hear. So he
Hmm.
said, "Does the Bible say anything about the Ice Age, about dinosaurs?" I said, "No." So then, "Do you believe that?" And then I know what he wanted to hear, so I said no. So he could just go. When he left, I told my mom, "I don't want to ever get Bible studies again."
Gotcha.
And my mom respected that, which gladly I still had to go to church with
Awesome.
her and still stay with the functions, but
Yeah,
at least that part of my life I didn't have to deal with anymore.
that's good. That's good. It's good when parents like listen.
Yeah, I know. She's been a
Their
great
values.
mom. She's been a great mom. You know,
Yeah,
she, I everything I am, I owe to her because she's always been the go getter and, and been an example for me.
that's awesome.
She didn't go to high school. When she was supposed to go to high school, she was working in factories helping to support the family, and she didn't go to high school, night school, when I was a little kid. That's my first memories of my mom is her going to night school to get her GED, and eventually became a nurse. And 2 years ago, she retired as a nurse with a BS, a BA in nursing.
That's awesome.
Are you watching the time, Mac?
I
Yeah,
am.
yeah. I'll let you go.
Um,
All
two
right,
things
everyone.
real
Yes,
quick.
sir.
Real quick. Bees just asked, why did your mom leave the JWs? Or we can answer that during our flashback. If it's
We'll
a long
answer that during
story.
the flashback.
Okay.
She left because they were too cultish. That's the
Two
simple answer.
cultures. Okay, fair enough. And then I have a question for you. Because you said you have 4 kids or one on the way, right?
One on the way, yes.
One on the way. So you'll have 4 kids almost. Pre-congratulations on that. But what do you have your kids watch? Because you just mentioned that you watched PBS. So do your kids also watch
They're
PBS or?
yes. Well, they watch everything. There's so much available, but they watch
Yeah.
PBS. My kids are into dinosaurs. They're into science. We're raising them atheists. My wife's also atheist.
Oh,
So
cool.
yeah, we got 4 more atheists to
There you
contribute to
go.
the world,
That's awesome.
and hopefully their kids.
And since you said dinosaurs, I'll say I just made the executive decision while my wife was at work. Me and my boys just watched Jurassic World the other
Oh,
night. I'm
awesome!
like, hey,
Yeah, yeah.
Oliver, do you want to watch? Do you want to watch some
Oh, but you watched the
dinosaurs?
new one, the new one, the Fallen
Not the
World.
brand new
No.
one. No,
Oh,
not
okay.
Fallen Kingdom yet.
No Fallen Kingdom. Yeah,
But he said he wants to go to theaters to watch it. We haven't taken him
yeah,
to
yeah. I
a
want to
sit
take my
down
kids
movie
too.
theater.
Yeah, yeah.
So yeah. So
No,
hopefully
you have to.
we'll get to do that. But she was scared that I was gonna terrify the kids with dinosaurs eating people, and then halfway
Nah.
through the movie, I'm like, "Hey, Bubby, what do you know? Like, do you like this movie?" He's like, "Yeah." I'm like, "What do you like about it?" He's like, "I like when they eat them." He's like, "Yes."
Watch that
I'm like,
kid.
"Good."
No, I'm just kidding.
uh,
No, that's cool. Those are the funny parts of the movie, anyway.
yeah, it is. It is. All right. Cool. Well,
All right, let me not make you
that's
late for
awesome.
work. We'll have to continue this.
Yeah, that sounds good. We'll have to. Thank you, chat, for joining in and asking really good questions. I really appreciate it. If
Hey,
everyone
you
could
guys,
do,
do me a favor too. Bug non sequitur and have them on me. Have them take me on their show.
yes, Bug non sequitur, because he'd be really interesting to have on the show, and Steve would have much better questions for you than I would. He has a
No
background in
doubt.
like everything to science,
Yeah,
with
yeah.
a great debate
Plus, he's a good-looking dude.
community. He is. He is one rugged man.
Yeah, yeah.
So if you could help us out and get Ed's name out there a little bit more, again,
Well,
on
like I
Twitter
said, they
as
invited me.
@Trisapient.
They invited me to their show, so I forwarded my ebook and some info. So
Awesome.
I'm assuming that he already said he responded saying that they're reviewing it. So
Awesome.
just you guys push him.
Yeah, push him. Well, please share this video, everyone. Like and subscribe. I think Ed's here. Are you thinking of starting a YouTube channel soon?
I'm gonna have to.
You're gonna have to. You guys
I'm
hear
gonna
that?
have to.
So don't let him. Sorry, go ahead.
I'm planning on doing courses, so I'm gonna have small videos explaining different parts of the so that people can, it's too much to grasp all in just one. It's impossible. So I'm
It
gonna have to
is.
make a series of small videos explaining different parts of the theory and how they all interact.
That's awesome. And then you could also do Q&A videos every so often because people are
Correct,
going to have
correct. Yeah,
questions and it's
yeah, of course.
and,
Yeah,
and you're really good at answering them.
yeah.
So
Oh, thank you.
I'll suggest real quick you should if you have a channel for YouTube just through your Gmail or
Yeah, I
anything,
do. I
or
do.
if
Yes.
you're going to make one, go ahead and add that to your Twitter so then I can tell everyone go subscribe to Trisapient. And
Awesome.
everyone, again, he's at Trisapient on Twitter. And
3
you guys
times
know where I
wise.
am? Say what?
3 times wise. That's what that means.
3 times. Oh, 3 times wives?
Yeah,
Lives?
because wise, sapient, like Homo sapient.
Mm-hmm.
They debated on saying making us Homo sapient. So I'm saying if they're saying it's twice as no Homo sapient, saying that we're twice as smart as our previous ancestors. So I was saying if they're twice as smart now, then I'm 3 times. Try sapient. Yeah.
It's so bold. Awesome. It sounds super cool though. Like
Yeah.
it has a really good ring to it. I
Ring
like
to
it.
it. Yeah, I know. I loved it.
It does.
I got it for IG, the infidel guy. I don't know if any of you guys know him. It's a long time ago.
Can't say I do, but I can. But I can
Google
look
him.
into it.
Google him. All right, guys.
Awesome. All
Have a
right.
good night.
Good night, everyone. Thanks for coming, and we'll see y'all in the next one. Good night.
Good night.
And